Okay, well, welcome. So I'm George. You can always call me George. Currently, I'm a director of applied scientific computing at the Frederick National Lab for Cancer Research. So in my role, I oversee medium-sized team taking state-of-the-art technology in data science and machine learning and making them available to the investigators within the National Cancer Institute who are studying fundamentals of biology, understanding cancer cells and tissue, or understanding or running some clinical trial with new drugs on patients and so on. So a lot of data coming up from the biology side have been digitized. So either we have a clinical unstructured clinical text, right? Some just like documents describing doctor notes, either about the patient clinical information or maybe reading a pathology or radiology image, okay? Or we have, as I just talked about, images, right? We have like digital images, either images on the cells that are within the tissue section, and we want to see how they interact with each other, or going a bit bigger, you have a radiology image showing a 3D scan of the body or a certain organ of the body, and everything in the middle. Maybe have also images of just a single cell with all the intracellular structures in there. All these are digital information that we can nicely analyze. So I've had taken one of my prior roles. I was a member of a secretary level project between the National Cancer Institute and the Department of Energy. Like, why Department of Energy is working with National Cancer Institute? Well, Department of Energy, if you just like Google it, you will find that they have the largest supercomputers in the world. Okay, they are in the Department of Energy National Labs. So you see, I am in the National Lab. Most of the national labs in the United States are part of the Department of Energy, and many of these national labs has leadership computing facility, which has a supercomputer. Supercomputer basically, it's you have a node that might have like 4 or 5 cores and like some GPUs in it, but not just one of these nodes. You have like hundreds of these nodes connected with high-speed network, right? So they can make simulations about everything you think about, either from simulating atoms in a cell all the way to simulating galaxies and the whole universe, and of course simulating the nuclear stockpile to make sure that the nuclear arsenal of the United States is still working without like launching nuclear weapons and trying them in the desert. Okay, so that's nicely that like some of these supercomputers are used for life-size applications, which is one of the projects. This is the project I'm talking about here, where we said, okay, we have this very large computing power. We have a lot of data at the National Cancer Institute to join forces and see how we can use these computers to find patterns in data that you have at the NCI. Okay, so that was this project. You can, if you are more interested, I can send you some links of what has been done. But before that, I was also a startup next door here, working on acceleration of medical image processing using graphic processing units. And before that, I also was graduate students like you at the University of Maryland. So I've been around this campus for 15 years. That's why I'm telling you, it just changes a lot. Okay, so what I look for when you finish the semester, if you successfully complete the course, you should be able to do 4 things, right? You should be able to describe a machine learning problem and define its input and output and how it can help solve a specific or help to serve a specific application. Okay, that you'll be surprised how many people I interview for various positions, and I tell them what you have done. Describe me a project that you have worked on in machine learning, right? And I usually, whenever you describe any system, it doesn't have to be a machine learning system, or a system that uses a machine learning model, right? You have to know 3 things, right? What's the input, what's the output, and what did you process in that system, right? And then you can ask more interesting things like, okay, what was your objective? How did you evaluate it? What were the bottlenecks? And so on and so forth, right? So if you want to take one thing out of the course, when you describe a system, describe its input and output, what have done. And in our case, we'll describe systems that uses machine learning models, right? So That's what I would like you to get out of the course. You are able to answer these questions. Somebody asks you, what did you do in the class? You're able to describe a machine learning model with input, output, and the processing that happened there, and then describe more of your experience. So once you get able to describe it, you're also able to go one more level to formulate this problem yourself, right? Say, now I want to solve a specific problem. What data do I need? What model do I choose? And how do I make these selections? Not just that, currently with all the frameworks that we have with this booming area of research and development, right? Almost anybody now can go and basically start training a model with few clicks or 3-4 lines of code, right? So, well, what do we get then from attending this course, right? Well, it's very easy to get something running, get the turn on the crank, right, to get things running. But what you really need to learn is that how do you get it to work to meet your objectives, right? And if it doesn't, what are the knobs you have to turn, right? That's where I believe you can write. Let's say you take your first programming course and you write your C function to do a certain operation, right? Well, that's fine. If you are an undergrad, you'll just write it down and then it will run, it will work, giving you the output, right? But later on, when you go to your third level course, when you start thinking about data structure and algorithm, it's not just enough just to get an output that gets a Fourier transform of a matrix, right? You might want to need some objectives, I want to need some time objective or memory objectives, right? And when it doesn't do that, how do you solve it? What knobs? How can you start interrogating the system? And this system, we will see it is based on statistics and patterns, right? So the answer is not, I'm going to run a debugger and follow the code line by line to find what the bug is. There's no bug in the code. The code runs and gives you an answer, but that answer is not what you're looking for. You're asking it to classify an image. It's not giving you the right classification, or you're asking it to segment a person in an image, and the error is very high. How do I reduce this error, right? So it's not just debugging code. You need to debug patterns, right? That's what we do in machine learning. We like to kind of field of pattern recognition. So that's what I would like you to get out of the course, right? Being not just somebody who can, as developers who can put together a few lines of code and train a model, but I want you to also know the knobs, know the ins and outs, and when you are working with a team, be able to ask the right questions and have the tools to suggest solutions that you can try next to get to achieve your objectives. Okay. So as we said, we need to we need to know that, but we also need to have hands-on experience, right? So as I said, we have a lot of frameworks that can do that for us now. Keras, TensorFlow, PyTorch, if you have heard some of them, that you would like you to have this hands-on experience to be able to use these frameworks. I'm not gonna be teaching these frameworks in the course. Why? Because these frameworks, you can learn them on your own. You don't really need me to teach you how these frameworks work. What we're going to be doing in the course is the fundamentals of deep learning. So basically, we will take the fundamentals operation that these frameworks support, and we will implement them from scratch, okay, using Python. What will that enables you to do is that next, once you know how it's implemented at a very low level, not super low level, at intermediate level detail, you're still using Python, right? You're not implementing it with C or any of that, right? You are mostly using NumPy, if you're familiar with NumPy in Python, matrix operation, and so on and so forth, right? Now you say, okay, now I know how these things work. How is it implemented in Keras? Just go and Google it and find out the tutorial of that, or ask ChatGPT, and it will tell you here is the function that implements the same functionality in Keras. What you will understand about this operation is that you will know what's its parameters and how these parameters change the outcome of your model, right? That's what you need to learn in this class. Not just how to use it, you need to know what's happening under the hood and what are these parameters, how does it affect the operation, right? So if we learn it, it's as if I'm telling you, you are programming with assembly. If you can program, have anybody know what assembly is? Raise of hand. or programming in C. If you can program in C, you can program in Java, in Python, or whatever, right? Because C is a functional language. You know, C++ is an object-oriented, and Java is object-oriented language. Like once you know the fundamentals, you know, what if Keras goes out tomorrow and something else came, right? You shouldn't worry about it. You already know how these things works, right? You know the ins and outs. It's just gonna be a syntax for you. Okay, and last part, I would like you to be able to address challenges and identify solution, explore opportunities that's coming up in this field. So you're all seeing this is like rising exponentially in terms of like the amount of research, amount of startups, the applications, right? So I'm not gonna be able to teach you everything in one course, right? You should be able to be in a place where you can go and read a paper or read an article about something new happening or something interesting for your field taking place, and be able to say, okay, that's useful for me. Would that enable me to do something new or not? Okay, so that's kind of what I would love to see you at the end of the course after you do your all your projects that we're going to talk about.